Introduction to vectors. We talk about vectors. We're actually talking about a unique one form that is able to translate an x coordinate and a y coordinate, as well as the magnitude behind it, into one simple format. Now let's talk about scalars. Scalars only have magnitudes. As I put here, 64 miles per hour, 250 feet, 9.8 meters per second squared. That's acceleration, by the way. To have you recognize Avogadro's number is 6.02 times 10 to the 23rd. These are scalars. They have no direction. The vector is a scalar with direction. 225 miles per hour going east, 250 feet in the z-axis, 9.8 meters per second squared at 90 degrees. I always want to realize when we write vectors, we've got an x-coordinate and a y-coordinate here, but the vector is one component, and this is vector AB. You can see the little symbol here above the AB. It looks like this. Make it a little bigger. Actually, let me draw it better. It looks like that. And the x-coordinate, when you write in columnar format, is on the upper part, and then the y-coordinate is on the lower part. If we look at vectors here, these are 4 examples. They're all starting from the origin. But the vector gives not only the direction, but the x and y coordinates from where it starts to where it ends. Vector AB is -4, 9. And here is AB right here. And if you notice, wherever the line ends, that B here is where the head of the vector is going to be. -4, 1, 2, 3, 4, and then -9. 1. Actually, that's it. 1, 2, 3, 4. Yes, 2, 4, 6, 8, 9. AC is going to be 4, 7. And notice it ends on the C here. So it goes 2, 4, and then that's for the x coordinate, and 2, 4, 6, 7. AD, vector AD, ends on the D here. So the D part is where the head of my vector is. And that is at 5, 2. So it's 5 on the x-axis, 2, 4, 5, and then 2 down the y-axis. And that's -2. AE, our last one here, is -7, -3. That means I'm going to go -7, 2, 4, 6, 7 on the x-axis, and -3, 2 and 1 is 3 on the y-axis. Now, what I also notice here is they can have the same magnitude, which is basically the same distance, same length, and the same direction, but on different positions on the xy plane. I've got vector AB here, right here, and then I got vector FE right here. Notice they're both the same distance. If I go, see, this is, looks like it's the 2's, so this is 1, 3, 5, 6. So this is 6 across, and this is 2, 4, 6 up, which is what this is right here. This is also 2, 4, 6 across, and then 2, 4, 6 up. And they are both have the same magnitude. And really that is going to be that x and y combined. That, if we use Pythagorean theorem, we can discover what the magnitude is, which I'll show you in the next slide. But it's also the same x coordinates, same moving x, same coordinate in the y. But they're not superposed on each other, so they have different positions. And because they both have the same x and y coordinates and the same distance, they're going to parallel. CD and GH are the same thing. These are also both parallel. And you can see how I can tell parallel. The x distance is 14 on both of them. The y distance is -7 on both of them. So I know these two, they're different vectors, but they're parallel to each other. And I can look at this here. Let's look at, that's 1, 3, 5, 7, 9, 11, Let me see. No, oh, I went too far here. 11, 12, let's see, 14. So, starting over here. So this is also 14 across. And if I look at this one here, this is 2, 4, 6, 8, 12. That's actually 12 across. Yeah, I thought I made a mistake here. So this actually should be 12 here. Let's cross this off here. I apologize. That's going to be 12. And let's see if my y is correct. And let's see. 1, 3, 5, 7. Yep, and that's correct. 1, 3, 5, 7. And you can see they're parallel. But these are two different vectors. They have the same magnitude, which makes the same length, and then the same x, y coordinates. Now, if I look at this vector right here, or these group of vectors, I got A, B here. And actually, as I taught you, this is backwards. This should be BA, because the head of the vector is ending on B. And that's going to be negative 7, 11. Let's go 1, 3, 5, 7 across. And that's 7 in the negative x direction, so it's negative 7. That's 2, 4, 6, 8, 10, 11 right there. CD is, let's see, it ends on D. So it's CD, there's vector CD, and the head is on D. So that's 1 right here. 1, 3, 5, 7, 9, 11, 13, 15. And then it's 2, 4, 6, 8, 10, 12, 14, 16 up. So that's vector CD right there. EF, and that should be actually FE looking at this because the head is ending on E. The vector FE is, according to this, I have negative 11. Let's see, there's 1 to the y-axis, 3, 5, 7, 9, 11. Good. And then it's 6, 2, 4, 6 up. So vector FE is negative 11, 6. And then GH ends on H here, so that's the second part. I suppose that's 8, 6. 2, 4, 6, 8. And then it's negative 6, so it'll be 6 down. 2, 4, 6. Yep, that's correct also. Now, it goes back to the Pythagorean theorem here. We can look at the magnitude of this. What is the magnitude? Well, this is vector A. What is the magnitude of A? I've got an x coordinate where the head ends and starts at the origin, and that is 15. If we look at this, this is where 15 is right here. And then the y coordinate is 20. Well, that's the distance across the x-axis, across the y-axis, but it's a vector. I want to know the magnitude. Use the Pythagorean theorem. X squared plus a squared plus b squared is c squared. 15 squared plus 20 squared is c squared. And looks like I made a mistake here. That should be 20 squared is 400, not 500. So that should be 625 c squared. And the square root of 625 is actually a more wholesome number than 26.93. It's 25. So I'm looking at here is this vector has a magnitude of 25. And how do I figure it out? I basically use the Pythagorean theorem. Here's my x squared. Here's my y squared. Or here's my x, my y. Square both those, I'll get my hypotenuse squared. And when I take square root of that, I get my magnitude.